Good morning, everybody. I am your morning host, Magin, and welcome to Environmental Awareness Day, or EAD. This event is more than just a conference where we invite people to talk and you to listen. Throughout EAD, we aim to give you a wider perspective of the current state of the environment and the latest efforts being made to protect it. So to help set the mood for the topics in store, allow me to invite to the front our introductory speaker. Coming all the way from the Philippines, he is an alumnus of the Erasmus Mundus SERP Plus program. He was also recognized by AYUPAC and the periodic table of younger chemists. Ladies and gentlemen, please give a warm round of applause to Dr. Philippn Gotico.
Hello. Okay. Thank you for that warm welcome. So, good morning, everyone. I want to hear you say it because the morning is not looking good, but we want to wake up in this day, okay? Good morning, everyone.
Good morning.
Okay, that's better. That's the spirit. So, I thank the SERP Plus committee for inviting me for the introductory speech. Maybe I'm right for the position because I'm just coming from someone who recently got a PhD last September and also coming from the SERP Chem group, as well as a young researcher who wants to learn more from all of the experts that we're going to meet today. So allow me to introduce you to the Environmental Awareness Conference today. So for today, I want to give a general global picture of the state of the environment and my own personal engagement with all of these endeavors. So first off, I want to show you this picture. I think this was the very first thing that come into mind, or my very first engagement when it comes to environmental awareness. So back in the Philippines, in our college, I think it was 10 years ago, we always have these outreach activities where professors invite students to go on to near communities and have some kind of outreach activities. And dump sites in the Philippines is very common. And I think it's one of the most evident picture that you could paint when you think of environmental awareness. We are all consumers, so we consume everything and then we put everything to waste as well. So if you look at the global picture, we're dumping a massive amount of global waste. So 2.12 billion tons of waste dumped every year. So this could be just a number, but if you could imagine if we put all of this trash on trucks, these trucks would need to go around the world 24 times. So that's how massive it is. And this is very massive because about 99% of what we buy actually ends up trash in the next 6 months. So we are all extracting all of these resources from the earth, making all of these good products that are really good, and we're using them, but most of the time, all of these products just go to waste. And most of these waste are plastic and styrofoam waste that ends up filling most of the volume of landfill trash. And then because of this problem of resource and waste, there's also a prediction that actually, currently, we need about 1.72 planets to actually provide the resources and absorb all of the waste that we have. So I got all of these numbers from the worldcounts.com, and it's a very good site if you try to look at it because it gives you real-time count on all of the good facts about the world. So this already shows you that something is alarming on this aspect of the environment. So when I was back in college, I was a material scientist, and back then I could not solve the problem as a politician or something. I could solve it as a material scientist. And what I can think of is, okay, maybe I could think of a value that I can get out of these trash products. So what I did was we collected real trash from the dump site itself, like plastic and styrofoam waste, combine it with another waste resource product of the Philippines. So Philippines is very popular for coconut trees. So we have a lot of coconut fibers. So we tried to combine these two, plastic waste and styrofoam waste. We put it on a densifying machine. So a densifying machine is just to melt away all of this plastic and styrofoam waste, combined it with fibers, and we end up with the fiber-reinforced plastic composite. And this composite was used as brick materials. It can also be used as tabletops or as fillers for furnitures. So I was very excited when we were able to improve the strength of these materials. But then as an eager kid, you see, okay, I want to save the world. So I went to join some competitions. Okay, we have this new kind of innovation. What can we do? So we were very eager to present this to people, but then there's always a bad connotation about it. So you see, the bad thing about this is that we're using a lot of energy cost to make this product. So when we try to compete with commercial bricks, it doesn't compete at all. Like, we need a lot of money to produce this compared to the commercial one. So, okay, we're not gonna go to that application. So maybe the next thing, okay, we can go high-end, because you can always sell now as artisanal high-end products and then you get profit out of it. But then the concern is always the hygiene, because all of these are coming from trash. So even if you densify it, you burn it, you're still having that kind of mentality that, okay, it's coming from trash. So I said, okay, maybe an individual effort is not enough. So I said, okay, I don't want to do chemistry anymore, material science, I want to go to the industry, because I think industry has that tool to actually spread an action, you know? It's easier for companies to do this. So because of that, I tried to join for 2 years Manila Water Company. So it's a leading wastewater and water treatment company in the Philippines. And I wanted to join that because I went to the dump site, and all I see as well is that all of this trash are going to the oceans or going to the rivers. So maybe there's something else to be done on the liquid part of this state, okay? So when I went there, okay, there's also a big problem with wastewater. So if you look at it in a global perspective, around 65% of people doesn't have sewage system. And this is a big problem, because if you look at the history of mankind, the time in the history where the population was maintained and boosted was when we invented toilets, because it helps sanitation, it helps healthcare. So this number is really worrying. And if you can see, around 155,000 of people die every year because of related diseases due to lack of sewage system. So this is a sad reality, but there's also a big opportunity for it. Because you see, we also have 45% of people who lack access to clean potable water. So you can think of it, okay, we have this very dirty ocean or river, maybe we can turn it to something that would be useful. And when I went to this company, it seems that the process is easy, so easy. You take all of the waste from your toilet, from all the septic tanks, and then you actually just put in some biological flux. So these are bacteria and microorganisms that you usually found in lakes and rivers, but then you concentrate it into reactor batches. So what it happens is that it hastens up the process of cleaning water. Okay? But these organisms are aerobic, and aerobic organisms need oxygen, so that's good. So oxygen, so actually we need to put a lot of energy to have these aerator tanks that just gives oxygen for these organisms. But what's good is that these organisms just need to eat food, which is the waste, and oxygen to live. And when they eat all of this, they get so heavy that they settle down, and then the rest is just clear water. And you see, clear water is coming out of the system. And all of the flux that are eating all of these carbonaceous component go down and being recycled back again into the system. So you can see it's some kind of a sustainable way, see? And I was very happy that, oh, it's really cool that from this we get the clear water. And what's more opportunistic about this is that from this, so this kind of water is enough to pass the standard of water to be dumped into oceans. So it's a standard seawater. However, you can do more treatments about it and actually use it for potability. So for example, you can treat it with chlorine or UV radiation and actually become more potable. So then it can, maybe it can help that number where they lack access to water. But again, when I tried to put all of these slides, do you think, well, what's a common denominator about these two engagements that I was in? Money, cost, yes, because the cost comes from energy. So there's still a need. Everything we do, we need to exert energy, and I think it's true. It's a requirement. To do action, we need an energy to do that action, right? In a global perspective, we use around 500 million terajoules of energy per year. And if you want to put this into perspective, this is equal to the amount of energy released by the Hiroshima bomb every 0.4 seconds. So that's a lot of energy. Just imagine that. And I think we know that most of this energy, so 81%, still comes from fossil fuels. And by fossil fuels, I mean oil, coal, and gas. Right? So it's not just coal, but all of these three components. And there was an estimate up until last night that it would take 33 years for this oil reserves to be depleted. So you see, there's a limited amount of resources. But then there's a good side. And what's that? What do you think? So this number, so it only takes 71 minutes of the solar irradiation to actually compensate to our demand for 1 year. So for me, that number speaks a lot, like 71 minutes just for this 500 million terajoule per year. But the problem with this renewable energy resource is that they're just becoming in demand, but their current percentage is still low. It's at just 4%. I think the main problem with this, okay, is that there is still the problem of CO2. So every time we use energy, we produce this CO2. It's around 500 billion tons every year. And we already know that the CO2 problem causes global warming. I think you all know the effects. But showing here is just a simulation of where India and China are the big producers of CO2, and most are accumulated in the northern hemisphere. But the good thing about this is that on winter we have this accumulation, but then it will come during June, July. This red color disappears. So what happens there? We see these green plants. And I think every time we see these green plants, I think it gives you hope. Like nothing is getting doomed. I know that we're doomed, but then I think there's hope. And that's what I like about it. If you look at the trend of the CO2 curve, you actually see this undulation where you have the high peaks during the winter, but come springtime, where plants and vegetation bloom, it goes down. So you can already think that reforestation can actually solve our problem. But then our problem is so urgent right now that we need a very radical solution. And you can see even though the plant absorbs and breathes the CO2 in and out of the world, you still see that at the end, the CO2 level is increasing. That's why I was fascinated with the biological process of photosynthesis. It's as simple as taking water, free sources of water, CO2, and sunlight, and at the end we get sugar. And sugar is a form of energy that we use to do work. So what if we try to follow this scheme? We use free sources and maybe make it a good or sustainable way of making energy. So now I was interested in the field of artificial photosynthesis, wherein it tries to mimic what is happening in the plants, trying to make water, CO2, free source of sunlight, and actually do it to produce energy or any valuable chemical. So here we use sunlight to produce charge-separated states. The holes are used to oxidize water to oxygen, and then the electrons and the protons are delivered into the other side, where it's being used to reduce CO2 into a fuel or any valuable chemical. For me, I was very happy, but if you think of it, I am doing basic fundamental research. But if I try to apply it into the world, it's not yet ready. It's still new, and it cannot solve the problem. So at the end, we see that we have this interconnected problem, as I've shown you on my own personal engagements, with solid waste, with wastewater, with air pollution, with energy crisis. And all of these are interconnected. And now there's a bigger and bigger advances of not just using or analyzing Earth as it is, but involving humans, because humans are the great factors. So humans may have done the problem, but we could also do the solution, right? So at the end, we need to have somewhat of an interconnected approach. So we're using science and research to advance things, but we need to back it up with technology that is readily available in the market, that could actually do something with our current problem. But at the end, it's not just about scientists. We need to have policymakers and businesses to back this up. Because as humans, we are facing this problem as a whole world. So we need to solve it as a whole as well. And then you see there, communication. I think this is one thing that I would like to to emphasize, because not a lot of people know the urgency of the problem. So if we just try to say or to act on our own personal ways of what we can do, I think it could do a lot. So at the end, we need to have this interconnection. We should break boundaries between all of these aspects and actually establish connections. And what I like more is that more than establishing connections, we need to do it in a global scale. We are facing in a global environment and a global change. So we need to do it. And what better way to start it is with this Environmental Awareness Day, or with this international group of people where each of us are from different countries and we can make our own difference. So I hope we learn a lot. To the next speakers, which are all experts in each of the fields that I've mentioned, and let's save the world.